Imagine peering into the most remote corners of the cosmos, places where light has been traveling for nearly all of cosmic history, billions of years, before softly landing on the doorstep of human discovery. In those farthest recesses, the universe holds secrets so profound, so unexpected, that their mere existence could rewrite the very story of how everything began. Today, we stand at a breathtaking threshold as NASA's James Webb Space Telescope, the most powerful eye humanity has ever lifted to the sky, has uncovered something absolutely extraordinary. Scientists at the University of Missouri, sifting through the delicate glow of infrared light collected by Webb, have identified 300 mysterious objects, cosmic beacons shining brighter and earlier than we ever imagined possible. These objects, nestled close to the dawn of time, carry with them the potential to shake the foundations of our understanding about how galaxies were born. If even a handful of them truly are what they appear to be, the very framework of cosmic evolution may have to be rewritten. Let's embark, together, on the detective story that is at the heart of this scientific revelation. In the vast, inky ocean of space, it begins with the subtle capture of ancient starlight. Using both the near-infrared camera and the mid-infrared instrument aboard JWST, two marvels of engineering designed to pierce through cosmic dust and across unimaginable gulfs, researchers set their sights on tracking down the very first gatherings of stars and galaxies. Why infrared? Well, there's a simple yet mind-bending answer. The farther away an object lies, the longer its light spends racing through the expanding fabric of space. As it travels, the universe itself stretches this light, pushing it from the visible spectrum into the deep, rich crimson of infrared. This phenomenon is called redshift, and it is nothing less than time travel in action, a map of how far away something is and how close it is to the universe's own origin. Astronomy professor Hao-Jing Yan explains it with a kind of reverence. As light from these ancient candidate galaxies reaches us, it arrives stretched, carrying with it a coded message of distance and age. The higher the redshift, the closer to the moment of cosmic genesis we're looking. To glimpse a galaxy at high redshift is to reach deep into the universe's own memory. How did the team at the University of Missouri identify their quarry among the countless pinpricks of starlight? They employed a clever and time-tested method known as the dropout technique, a process that, in the hands of experts, becomes a cosmic sifting pan. Imagine looking for objects that appear bright in the redder bands of Webb's vision, only to find they simply vanish entirely in the bluer wavelengths. This vanishing act is a telltale sign that light has been stretched well beyond the ultraviolet thanks to the absorption by neutral hydrogen billions of years ago, a feature known as the Lyman break, drifting ever further toward red as the universe ages. Bangzang Tom Sun, leading the study as a dedicated PhD student, points out that this technique can spot those telltale signatures. As the redshift grows and grows, entire galaxies become dropouts, blushing their way into existence solely in Webb's deepest filters. But finding a hint of a galaxy is not the same thing as understanding its true nature. The journey next took the researchers to a place where painstaking analysis meets scientific creativity. Normally, astronomers would use a technique called spectroscopy, the gold standard, to spread out the faint light of their cosmic suspects into a rainbow, measuring the unique fingerprints that reveal everything from distance to chemistry. However, when the universe is this faint and its objects this remote, full spectral data is not always available. So the team turned to spectral energy distribution fitting, a method where patterns in the glow itself, color, brightness, shape, allow for an informed estimate of cosmic distance, age, and mass.
With this approach, every single one of their 300 dazzling mysterious candidates was scrutinized. And here's where the truly thrilling, perplexing challenge arises. In the past, astronomers might have dismissed such bright early signals as mere imposters, objects much closer to us, masquerading as ancient galaxies through cosmic sleight of hand. But Sun and Yan, armed with Webb's stunning sensitivity and their careful analytic approach, saw reasons for pause. The universe, it seems, may be more productive, more surprising than prevailing theories are prepared to admit. If only a handful of these gorgeous early candidates pass their final test, cosmology itself will have to expand, perhaps accepting that galaxies could form faster and shine more brightly at dawn than we have ever conceived. And here, in the grand dance of discovery, we must pause to marvel at what exactly it means to see a galaxy so unimaginably far away. The answer, in its own way, is deeper than the objects themselves. As some passionate voices online rightly point out, we are not seeing whole, fully resolved galaxies in the way we might envision, but instead we are catching ancient photons, traveling on their unimaginable journey of billions of years. The images, often rich in color, are the sum of incredibly faint signals pulled together and enhanced, made meaningful by cutting-edge science and technology. There are those who question, and their skepticism is a part of science's unending dance, that such distant sights are truly possible, that our instruments are capable of it. Yet every calculation, every confirmation reminds us humanity has indeed built telescopes like JWST that serve as cosmic time machines, capable of peering back to moments nearly lost to memory itself. And what did the Webb reveal exactly in this case? The catalog built by Sun and Yan, based on the careful dropout technique and spectral energy fitting, contains a wealth of extraordinary possibilities. The final, most decisive test, spectroscopy, is ongoing. It alone can capture the unique spectral barcode that locks in a galaxy's birthplace in time. For now, out of the 300, one object has already been spectroscopically confirmed as a genuine high redshift galaxy, a glowing ember from the universe's youth. This lone confirmation is a wonder in itself, but it is not yet enough to overturn or affirm the prevalent ideas of how galaxies rose from the cosmic dark. More confirmations will follow, each with the potential to push the boundaries of knowledge even further. Yet, amid the rigor of research, Webb's discoveries have sparked something just as vital, a surge of human curiosity, wonder, and sometimes even a healthy dose of skepticism. Commentary pours in from across the world. Some marvel at the idea that such objects shouldn't exist, a phrase repeated with awe and a touch of playful dissent. We are still a primitive Type 0 civilization, one observer playfully notes, urging humility in the face of such enveloping mystery. Others, with a spiritual sense of the cosmos, see echoes of creation, the vastness of the heavens rousing faith and reverence. And still others debate the very methods of science itself, wrestling with concepts such as light years, the stretching of time, and the boundaries between reality and imagination. But this, in truth, is the heart of the cosmos, a place where each discovery becomes not just fact, but invitation, a call to all of us, scientists or stargazers, believers or skeptics, to imagine, to question, and to seek the beauty hidden just beyond what we thought possible. The universe does not yield its secrets easily. It asks us to look deeper, to refine our tools, and to check every assumption. Webb's 300 candidates glowing in the deep beyond are both challenge and promise. Will they rewrite the timeline of everything? Or will they instead become stepping stones, each one illuminating a cosmos even larger, older, and stranger than we have dared to admit? So, as the James Webb Space Telescope wheels through its orbit, quietly harvesting ancient photons from across the abyss, we find ourselves drawn ever onward. Gazing up from our small blue planet, we reach across science and wonder, across time and uncertainty. The 300 mysterious beacons discovered by Webb whisper that the universe is not done surprising us yet, and perhaps they remind us, gently, that the greatest discoveries are not answers, but questions ever renewed. In this shared journey of awe and curiosity, let's keep exploring together, with minds open wide to whatever cosmic wonders await. The universe and all its dazzling complexity is still inviting us to search, to discover, and to marvel, side by side, star by star.